Right, so the slope of the graph from a dt graph gave us our velocity for this for the intervals. Okay. Now, acceleration. Do you know what acceleration is?
Yes.
What is acceleration?
The rate at which you're speeding or slowing.
Okay, so that's not a terrible way to look at it. That's pretty good. It's the rate of change. Okay, it's the rate at which you're changing your speed at, and is what we're going to look at. So that means then that I take my change in velocity over my change in time, which is equal to v2 minus v1 over your time interval, which again we go t2 minus t1. Okay, so we are also going to look at a velocity time graph today, in which our y-axis now, instead of being a displacement, is going to be a velocity. So I'm going to be able to demonstrate using velocity and time, okay? And again, by finding the slope of that line, I'm now going to get the acceleration on the graph, or from the graph. Okay? You follow this so far? All right, so yesterday I began to, poorly attempted to, talk about what happens when we drive to Yorkton. Okay, so what I want to do, the reason I wanted to use this is because it allows me to do two things. Number one is we sometimes forget how to find how far I've gone distance-wise. We can't seem to remember how to do it. So this graph shows me a real easy way of remembering how to do it. So first of all, again, like I mentioned yesterday, I start right here at the hospital. So I'm basically starting from a dead stop. I'm going to increase my speed until I hit 100 kilometers an hour. At 100 kilometers an hour, just outside Ford, I'm going to set my cruise control. And let's assume for all intents and purposes I'm allowed to go 100 kilometers an hour without taking my foot off your accelerating or decelerating. So I'm just going to go at a constant speed, okay, for 100 kilometers an hour. And then I'm going to slow down until I hit the lights. All right, and so that's my trip to Yorkton. I have an acceleration part in which I go from the hospital until I hit the 100 kilometer an hour sign at Ford. Then when I get close to Yorkton, I take the cruise control off and I slow down until I come to a stop. So for the first part of this trip, from here to here, I'm accelerating. Okay? So depending on how long it takes, all right, I'm going to be accelerating. Right here, I'm going at a constant speed. So I'm going 100 kilometers an hour. So when I had that flat line on a dt graph, it meant that I wasn't moving, right?
Yeah.
But on a velocity time graph, it means I'm moving.
But you're not accelerating.
I'm not accelerating or decelerating, but I'm going at a constant speed. So one of the things that we're going to do today is we're going to be able to find out the displacement in which I go. Now, acceleration is equal to v over t, right? If I wanted to find the acceleration here, I find the slope of that line. We know that. But what if I wanted to find the distance covered in that amount of time? Well, what I can do, and this is the first thing that's brand new to you today, is I can find the area underneath that. I know my base will be whatever time 0 here to whatever time 2 would be right there. Okay? My height would be velocity, which is 0 right now, to whatever my velocity 2 is up here. And I can then find the area underneath this triangle, inside this triangle, which is going to give me my displacement. Okay, so that's kind of hard to kind of figure out right now. But here's what I'm going to say to you. let's say I set that cruise control for 1 hour. Let's say I set my cruise control for 1 hour down here. That's my time interval, right? And what is the constant velocity that I'm going at? 100 kilometers an hour. So if I go 100 kilometers an hour for 1 hour, how far have I traveled? 100 kilometers, right? So basically what I did is I took the time and I times it by the velocity at the constant speed that I was going at, right? That gave me my displacement right here, which is the distance I traveled for that amount of time. So now I'm slowing down. I have another triangle. So I can then find my displacement there as well by finding out what the area of that triangle is. So if I know the time interval and how fast I went to begin with and how fast I was going at the end of it, I could subtract them and I could find out what that is. Then I would multiply them, divide by 2, and I get the area. Hold on, I'm going to make this all clear up. I'll show you an example and then it'll make more sense, okay? Okay, so the first thing I need you to do is understand that when you're finding the displacement in a velocity time graph, you just simply calculate the areas for the sections. That will give you the displacements. Okay, so far so good. All right, and by finding the slope, what am I getting when I find the slope of each line? From a VT graph, what does the slope tell me?
Acceleration.
Acceleration. What is the acceleration right here?
Nothing.
Zero. Right? Because I'm not speeding up, I'm not slowing down, I'm going at a constant speed. Fair enough? Okay. So let's tie it in and let's make sense of this, looking at an actual graph with numbers. And then it'll all come together. So look at page 62. I have, again, 5 sections this time. So I have A, a B, a C,
You should write that down.
and E. Yeah, let's write it down. Okay? All right. And I want to find velocity, time interval, acceleration, and I'm going to calculate my displacement.
On page 62, right?
Yeah. All right. On the graph for section A, what is my change in velocity? What am I starting at?
0.
0, and how fast do I get going to? 4. So what's my change in velocity? Okay, so let's start with that guy. 4 meters per second. And how long does it take me to get to 4 meters per second?
2 seconds.
2 seconds. Okay, let's do that. Let's just worry about velocity and time for right now. In B, what is my change in velocity? The change in velocity be 0, but how fast am I actually going?
4 meters per second.
Okay, so I'm just going to, there's basically what I'm going to do, I'm just going to divide this into 2. There's 0 meters per second would be my change, right? Which is going to affect, essentially is going to affect my acceleration, correct? But I'm still going 4 meters per second. And how long do I go 4 meters per second for?
For 3 seconds.
3 seconds, okay. In section C, what is my change in velocity there?
You're slowing 2 meters per second. Negative 2 meters per second?
Okay.
No.
You drop -7, but not.
Say that again, Rowan.
You drop -7 meters per
Yeah, I go down, right?
Yeah.
Okay, so a negative velocity means what?
You're slowing.
Deceleration.
Or,
Opposite direction.
remember,
You're going in the other direction.
you could be changing directions too, right? So that all comes into it. So am I slowing down? Yes. I slowed down, but I'm now going in the opposite direction because I went below that line. So I'll explain that in a minute. So anyways, for that, you said it was -7 meters per second, right?
Yeah.
because I would take a -3 and subtract 4. That would give me a -7. How long did it take to do that?
3.5 seconds.
So from 5 to 8, not quite 9, yeah. You said it right. 3.5 seconds. Great. D, what speed am I going in D?
-2. -3.
-3 meters per second. And how long am I doing that for?
That's
2.5 seconds.
2.5 seconds.
2.5 seconds. Okay, great. And then in E, I'm going back into the positive, so that would be 3 meters per second, agreed? So from -3 to 0. And
3 seconds.
3 seconds. Okay, perfect. Okay. So, operation number 1. What we want to do is we want to find the slopes of those lines to find our acceleration. So in A, what is our acceleration here?
2 meters per second.
2 meters per second is a speed.
What?
2 meters per second.
Right.
What's the units for acceleration? I'm
Meters per
taking,
second squared.
yes, very good. Okay, so that's first thing. 2 meters per second squared. Meters per second squared is your SI units for acceleration. Okay? In B, what is my acceleration?
4 meters per second.
1.3.
No.
All right. What's my change in velocity in that one, guys?
Oh, not
0.
So I didn't
0.
accelerate. That's right.
Ah,
That's why I was a little leery about putting the 4 meters per second up. I did that for the distance part. Anyways. Okay. So now I have C. My change in velocity is -7 over 3.5.
-3.5.
So it's going to be -2 meters per second squared.
Oh, sorry.
Right? Okay, no, that's you. Okay. Now I've got to take D,
0.
0 again. That's right. That's right. And finally,
1 meter per second.
1 meters per second squared. Okay, great. So there's the accelerations in all of them. All right? So I have 2 meters per second squared, 0 meters per second squared, -2 meters per second squared, 0, and 1 meters per second squared. Okay, now, to find the displacement that I traveled. Okay, so first of all, when I look at the velocity time graph, I went in a positive acceleration, and then I went at a constant speed, and then I slowed down, and then I changed my direction, so I sped up going in the opposite direction. Then I went at constant speed, and then I slowed down again until I got back to 0. So eventually I started and I stopped. Now let's find out whether or not I got back to where I was supposed to.
No.
Distance-wise, let's find out. Okay, so in the first part, I have a triangle for A. What's my base in A?
2.
2. What's my height?
4.
And how do I find the area of a triangle? Base times height divided by 2. 4 times 2 divided by 2 is 4. So, distance, 4 meters.
Alex is waiting for that question his whole life.
Sorry?
I said Alex is waiting for that question his whole life.
He nailed it. He was ready. He was ready. All right. So in the second part, how fast am I going in B?
It's the same
4.
speed.
4 meters per second. For how long?
5 seconds.
3 seconds.
Yeah, no, it's 3 seconds, isn't it?
3 seconds.
Yep, I have a
12
meters.
So he goes 12 meters. So currently, how far is he away from his starting position?
16 meters.
16 meters, right. Okay, now in C, we are going to follow above the line only. Okay? So that's from 5 seconds to 7 seconds, agreed?
Yep.
Which is a base value of
2.
2. Height of
4.
4. So 2 times 4 divided by 2 is
4.
4 meters. So the furthest he got away from where he started is how far?
12 meters.
16 meters.
4 meters.
No, it's 12. 12 is the furthest.
Gotcha, you got it right.
20 meters.
20 meters. He went 4 meters in A, 12 meters in B, and another 4 meters in C.
Oh, I thought they changed.
Just wait. Just wait. That's how far he got away.
Okay.
So he's 20 meters from where he started. Now when you go below the line, now we have to take into account that there's a negative value, meaning you went in the opposite direction. So now on C, you've got from 7 seconds to 8.5 seconds, which is 1.5, right?
Mm-hmm.
And 3 is your height. So we got to go 1.5 times 3 divided by 2. Anybody?
2.25.
2.25. So that's a negative 2.25 in that section as well.
And C? Oh, yeah.
Right? Just that last little bit of C?
Yeah.
Okay, now in D, he's going from 8.5 seconds to 11 seconds, which is 2.5 seconds, right? That's what we decided. And he's going at a speed of negative 3 meters per second.
Yeah.
So when I multiply 3 by 2.5, what do I get? So this is a negative 7.5 meters. And in the last part,
Positive. Speeds up.
so he's going,
He's
Slowing down.
his base, technically he's slowing down, right? He's just going in the opposite direction. He's not speeding up.
up here.
Okay, so from 11 to 14 is 3 seconds, agreed?
Yeah.
And he's traveling at 3 is a height. So 3 times 3 is 9. 9 divided by 2 is negative 4.5.
Wouldn't it be positive because it's coming back?
No, you're,
Oh,
okay,
he's
just
still
think
in the
about it.
negative spot.
Think about it in terms of the graph.
Yeah.
You got a negative 3 as your height, right? So negative 3 times positive 3 divided by 2 is going to give you a negative value.
Okay.
So even though it looks like you're going,
Yeah.
you're not. That's not direction. The velocity is not like looking at that graph. It tells you which side you're on, but you're still going in the opposite direction. Okay. So let's look at our chart to begin with. Easy part of the chart was the change in velocities, right?
Yeah.
Time's actually the easiest part, so time's easy. Acceleration, all I did was find the slope, agreed?
Yeah.
Okay? And then the distance, I just used the areas underneath the graphs with the x-axis to find out what my distances were. Okay? Now, here's the thing that we need to be able to do. So this is where it gets a little complicated for you. We need to be able to take from a velocity time graph, we need to be able to draw an acceleration time graph. And from a velocity time graph, we need to be able to draw a distance time graph. Okay? All right, so from the velocity time graph, I look at it like this. This is my middle graph. That's my middle graph. So I can go up and I can go down. But I can't go from a DT to an AT, and I can't go from an AT down to a DT graph.
So if they ask you to go from there, you have to go to the
You
middle
can't.
one first?
No, you don't. We won't ask that.
Okay.
All I need you to be able to do is go from a BT to an AT and a BT to a DT. All right? And then a distance time, you can draw a velocity time as well, but we'll worry about that after. Okay, so I'm going to show you right now how to quickly draw the acceleration time graph from the information that was given. So it's going to look like this. I draw my axes first. What was the largest acceleration I had?
2 meters per second.
2 meters per second squared. So 2 meters per second squared is right there. So this is acceleration here. Okay. What was my minimum acceleration?
0. Mine's negative. Yeah.
-2, right?
Sorry, I didn't see that.
Minus 2 meters per second squared. Okay, so far so good. All right. My intervals. The intervals stay the same. So I've got 2, I'll just do this, 4, let's see, 6, 8, 10, 12, 14. Does it go to 14 and that's it, right? Okay. So this is actually a very simple thing to do. It looks kind of goofy, but it's very easy to do. And it works like this. From 0 to 2 seconds, I was going 2 meters per second squared. Okay? So I just draw it in terms of a block,
Oh, yeah.
like that. All right?
Why did you come down?
Because my next acceleration is 0. Right? So for the next 3 seconds, I go 0. Right there. And then I go down to minus 2 seconds. So I drop it down to here. And I go minus 2 meters per second squared for 3.5 seconds. Goes right to there. Everybody
You don't
follow
bring
me?
it back up though?
Is
I'm
that
going
to
to.
9
I'm
or
going to
Just
10?
1 meter per second.
Is that to 9 or 10?
That's 8.5. It's hard to tell, but it is.
Or
I may have went a little bit too far. There. I think it was 8.5, right?
That's to -2, right?
Okay, that's negative 2. So now I gotta go back up here because what do I go next? 0 until 11 seconds, right? Like that. And then I finally go 1 meters per second squared. Oh, I did this wrong. Sorry, I started wrong. I'll fix it. So it should be this to start with. Okay? And then when I go here, 1 meters per second squared to 14. There's my graph. There's an acceleration time graph. You just do it as boxes.
Do you close that last one?
No, you don't have to. You can leave it as is.
You don't go back down to 0.
Well, because
Well-
you started 0.
Yeah. Well, we could. You can. If you want to close it, it's fine. If you didn't close it, I'm okay. There it is. There's your acceleration time graph from that chart that we just got off of the VT graph. Okay?
Yeah.
So, Mark, you should put that down somewhere in your book right now. I would mark it down right now. Okay?
Okay, it's maybe a dumb question, but
Mm-hmm.
this, when it goes up here and it goes down, so what's happening in this period of time?
Slowing down, it stops, and then it changes its direction.
I think it's 15.
Like, so why would it go into the negative?
Because that shows you that it's changed its direction.
This is this last
And then when it goes, that's
So you're still going in the opposite direction. That's constant speed going in the opposite direction you started with. I might be able to tie it into this distance time to make it make sense to you, okay? Okay, so now I started home base right here. After 2 seconds, how far away was I from home? How many? 4 meters. So I go right here.
How many meters will it go up to?
20. Okay? For the next 3 seconds, I added on another how many meters? 12. So now what should I be at after 5 seconds?
16.
16, that's right. So after 5 seconds, I'm 16 meters away from where I started. And then after 7 seconds, how far am I away from where I started? Who's not following here? Put your hand up.
I did not do that.
For me?
I just did copying that graph, but now I'm paying attention.
So I went 4 meters in the first 2 seconds. I went 12 meters in the next 3 seconds. And 4 meters in the next 2 seconds.
How do you have two numbers like you have? Yeah.
Well, because I found the area here first.
From B?
No, for C. Above the line.
Oh, above it.
And then I found for C below the line. That little piece below it. So that's why I have 2 numbers. Okay, so after 7 seconds, right here, I'm at 20 meters. That's the maximum distance I am away. That's my maximum distance I am away from when I started. And after 7 seconds, the vehicle stopped and changed its direction, right? And then it went 2.25 meters. So right now I'm at 20. So now I'm coming back towards where I started. And I came back 2.25 meters. So after 8.5 seconds, I'm at 17.75. That's right. So about right there. So that would be 17.75. I'm just going to mark that in there. Just so you know. So I'm already coming back in the opposite direction. So where is this found on that graph? Where's that found on the graph? Down here. I'm just taking the distances from what happens from the information on the bottom part of the graph. Okay? So now, after 11 seconds, I'm another 7.5 meters closer to where I started. So where am I at now?
10.
10.25. So at 11 seconds, I'm at somewhere right here.
What's the second last? That's 17.75?
Yeah. What are you lost about?
Well, because I've got this point at 16 and 4, but then
You got, say that again.
like at 16 meters and 4 seconds.
5 seconds. Austin, after 2 seconds, I'm 4 meters away. After 3 more seconds, that makes it total how many seconds?
5 seconds.
I'm now 16 meters away. After another 2 seconds, I'm another 4 meters away.
Okay.
So after 7 seconds, I am 20 meters beyond where I started. Then you look on your graph, it goes now below the line, which means I've switched directions. So now, after 1.5 seconds, I'm 2.25 meters coming back.
Okay.
And then I'm another 7.5. So finally, after 14 seconds, I need another 4.5 closer to home. So 4.5 away from this is what?
5.75.
Right there.
That's right at 14.
That's right at 14. Okay? So, if you just don't look at the graph for a second. Hammer, what are you doing? If you don't look at the graph for a second, okay, I'm going to work through this. All right? Just follow me. After 2 seconds, I've gone 4 meters. Correct?
Yep.
After 5 seconds, I've gone another 12 meters. So how far am I?
16 meters.
16. After 7 seconds, I'm at 20 meters. Okay? Now on your graph, where is the graph located after 7 seconds? Look on your graph, on your original graph. 0. You're at 0, right? On your original graph. The one in the textbook, Emma.
Oh,
At 7 seconds, where's the line? I'll go.
Zero.
Never mind.
0.
It's at 0, right? So now, it goes below that line, right? That means I'm starting to go in the opposite direction now.
So does that mean, let's say you were in a vehicle and you're like, turn down?
Yes, exactly. That's what that means.
That's
And that's the part that throws everybody. And that's the part I expect to have confusion, so that's why I'm explaining it. as best I can here. Okay, so now I start going in the opposite direction. So after 1.5 seconds, so that's the first part of the slope, I'm now going in the opposite direction. I've got 2.25 meters. So coming back. And then I'm 7.5 meters because that's the D. Look at D on your graph. You're going minus 3 meters per second for 2.5 seconds, correct?
Mm-hmm.
So I multiply those and I get negative 7.5.
Then you start slowing down. You get closer.
I keep slowing down closer to, to a stop again. And but I stop short. I stop 4.5, stop at 4.5 meters. So I end up actually, so if I were to ask you your displacement, let's say that the top of the graph was north and the bottom of the graph was south. What is the total displacement? What is your displacement in this particular question?
5.7. No.
5.75 meters to the north. You're absolutely right. You're absolutely right. Does everybody follow that?
Yeah.
So it's hard to see because if I drew it on a number line, it would make more sense to you. But then when I put it on the graph with the time part of it, it gets a little more confusing. So what's happening here is, and that's why I changed my colors of pens. The green represents everything to the north on that graph. The blue right here represents everything on the south of that graph, meaning it's coming back towards it. Is that a little bit okay?
Yeah.
So?
What's the second?
No, I expect that. But that's why we're going to work the next 3 or 4 days on this. Yeah, go ahead.
So you could just do like all of the yellow, take away all.
Yes,
You get your answer.
that's what you get your answer from. That's 100% right.
All of the yellow, take away all of the what?
Blue.
If you add this up and subtract the black right here,
You get your
you get
your
right there.
displacement.
That's what I mean. If I put it on a number line, and I drew it on a number line,
You just be canceling, basically.
Yeah.
Okay.
it would go all the way here, and then you'd come all the way back, but
If
you'd
you-
stop short.
If you ask us through a graph with a number line work.
No, because you have to show distance versus time. Distance versus time.
Yeah.
Okay? What do you say? So?
Yeah.
So?
I don't agree.
Okay. Average acceleration, I don't focus a lot on it, but average acceleration works very similar to average velocity. You take your final minus your initial, and then over whatever time interval it is. Doesn't matter what happens in between. You take your final minus your initial to get it. Okay? An example of all of this is on page 69 where they give you the VT graph in the middle. So go to page 69. They give you the VT graph in the middle there on the margin. In the margin there. And then you go to DT on top and an AT on the bottom. So I kind of flip them. All right. So you take all your information from the middle VT graph and you create your D graph and you create your AT graph on the bottom. So far so good. That probably given enough time.
So this.
The first
So
graph.
this.
The first graph is acceleration time?
Yes. AT.
Okay.
Yes.
This graph is just made into a whole bunch of graphs.
No. That one's separate. That's a practice. Just the three in the margin on the right,
Yeah.
they're all together. So the middle graph, that's the beginning graph.
And then it splits up.
And then you get your distances from that graph to get your top graph, and you get your slopes from that graph to get your bottom graph.
That's-
Okay, so let me put that in writing so maybe I can do a better job of clarifying that for you. So from a VT graph, I can go to an AT graph by using slopes. Okay? And from a VT graph, I can go from a VT to a DT by finding areas. Okay? I can't go there to there. All right? I can go from here to here,
And switch.
but we won't have to. We can go from an AT to a VT.
We won't.
You can, but you do not have to ever go from an AT to a DT or DT to an AT. Okay?
You can't or we won't.
We won't. You won't and you can't.
You can't. There's no.
And we're not asking. Okay? All right, so far? So, the biggest thing that I wanted to point out to you today was this right here. I stressed this a bit yesterday, is if you can create your charts,
It'll become easier.
then everything just like, I didn't have to look at the drawings in my book to create those other two graphs. I just had to follow the information that was on here to do it, right?
Yeah.
So as long as you can do this guy, you're off and running for that. So how did I get my A's from my VT?
The slopes.
Slopes. And how did I get my DTs? My
Areas.
displacements? The areas. Okay? All right, we have a number of days in which we're going to work on this. We'll work on this today and then again all day tomorrow. On Monday, I will go through the actual equations that are our foundation for physics. We use these 5 equations repeatedly all the way through to the end of grade 12, amongst a lot of other ones, but the 5 that we're going to learn tomorrow are our primary ones, or sorry, we'll learn Monday, are our primary ones, and that'll get us through. So, how many of you got done all of yesterday's work?
I
I
forget
think
what it
they're
was.
pretty close.
That was the like 45, 46, and
49, yeah.
So,
Okay, you have, okay, so what I'm going to add to the list of yesterday, all right?
this is what we'll have done for Monday.
Yeah. So you're going to have the rest of today and tomorrow to do this. So write this down then. What was the last page I gave you yesterday?
52.
52?
You gave us 49 too.
No, it's 49.
49 and 52.
Practice on 52.
Okay. So the next one you're going to do, I want to do instantaneous. I'll have to explain that. 59. So write down that, 59. $62. There's only one question on each of those. 65.
Oh, but let me see on this.
There's only one question on 2 of those pages.
Oh, but that's perfect. Just keep it that way.
And 69. So for those of you that are here tomorrow, it probably shouldn't take you all day tomorrow to do it. And so we'll maybe dabble a little bit into the equation, just get you started, but that's it. Okay, so you've got 35 minutes today and like 70 minutes tomorrow to kind of get your handle on this. I may give you a worksheet tomorrow if you get done, just so that you have practice questions to do. All right?
Will it be for Max?
No. No, I just want to work. This is just we're still in the learning process. Okay, any trouble with yesterday's?
Yeah, can you do question 3 on page 46?
Oh, yeah, I got that.
Okay, I'm just gonna shut the camera off. Okay, everybody look at page 46, please.